The first one is introduction. Basic argument mining is like given claim and premise, determining the relationship between the two arguments by our model. After that, we will have a question. How does the model get such prediction results? Therefore, we need to research models' explainability to provide the evidence of prediction for us. This is an example for our text. Given Q, R, and S, we want to predict Q prime, R prime. R and Q are argument sentence. S is the relationship between R and Q. Q prime, R prime are subsequence. Let's look at the table. We can understand the relationship between R and Q is agreed just through Q prime. It makes of cell idealization and R prime. Your thinking here is right. So Q prime and R prime provide critical information that is enough to decide the relationship between Q and R.
The first method we try is name entity recognition because we think that NER can determine which word may help understand the whole sentence meaning. So we do BL tagging, spill the training data into 4 input types, and then train the model. But the prediction of the sentence are not easy to understand, and also the submission result is not good, so we change our way to solve this problem. In order to make the prediction result be a readable sentence, we then use a pre-trained summarization model, text-to-text transfer transformer, which proposed by the Google research team. It's a shared text-to-text framework and can do translation, classification over many other downstream tasks. After fine-tune our T5 model, we find that for long sentence, the summary result seems more consistent with the training data output sentence format, but for short sentence, the result may contain new words that not appear in the source text, so we then further analyze the relationship between text length and summary result.
We learned in the previous method that the T5 model performs well in long sentence, but in the short sentence, it will generate additional wrong words. So we observed the training set. We found that in short sentence, there are many examples where the input is equal to the output. So directly using the original sentence as the answer can get a good score. Based on the above two observations, we hope to let them complement each other. So in the end, we use the T5 model to make predictions on long sentence. And a part of short sentence directly copy the original sentence as the answer. In the end, we improve our performance. The public score increased from 0.70 to 0.79, and the private score increased from 0.71 to 0.84.
The slide shows our journey of the competition. First, we use NER to train on the whole dataset, but we only get poor results. And we found out that using the original testing dataset as a predict result can get good score. We set it as our baseline. By further data preprocessing and investigation, we get higher score by sentence length testing. Then we combine the sentence length and the T5 model, BERT model, and the MLMC model, trying to improve the score by changing the model, hoping to find out the model best suited for our use case. I think the most significant improvement is done by data analysis. Found out that the sentence testing can significantly improve our score, which again shows the importance of the data analysis. I think the score can still be improved if we can use larger model or use more epoch to train, which both require more powerful computing resource. So that's all for our presentation. Then thanks for listening.